Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. So today, I'm gonna presenting about my journal review in the course of Trends in Science Education, and my interest field is problem-based learning in science learning. All right, let's jump to the first paper. The first paper is about effectiveness of problem-based learning on secondary students' achievement in science, a meta-analysis. So this paper was published in 2021 by written by Funa A and Prudente M. The background of this paper is the new era of education requires the sharpening of the 21st century skills, the 7 C's. As we know that the 7 C's is critical thinking, creativity, collaboration, cross-cultural understanding, communication, computing, and ICT literacy, and career. All right, so another background is utilize meta-analysis to analyze and examine the effectiveness of PBL, particularly on secondary students' achievements in science. All right, so the purpose of this research is to know the effectiveness of problem-based learning on secondary students' achievement in science. All right. Specifically, the researchers aim to answer how effective is the PBL approach in secondary students' achievement in science. Is there any significant difference between the effect sizes of junior high school and senior high school students in relation to their learning achievement using PBL in science? And is there any significant difference between effect size in students' achievements in relation to the scientific disciplines? And what were the PBL teaching strategies that have been investigated? All right, so the researchers use meta-analysis research design, which is a core movement to systematically synthesize the quantitative results from a collection of evidence-based knowledge, depending on the purpose of the study and data that are available. All right, so in here, in this picture, there is the step to do the meta-analysis research is identification, screening, eligibility, and included. Identification phase or identification step is about collecting the paper from through database searching from such as from GStore, ERIC, and then Google Scholar, and etc. And then the researchers will collect the paper that talk about problem-based learning, and then they will screening it. The screening step is only what not reading the full text, but only screening it, like reading just the abstract or the title of the paper, and they have a categorized uh, that they use to eliminate un, un, unnecessary paper for them. So they only take the paper that is talk about problem-based learning and in secondary level, in science secondary level, and it is evaluated students' achievement. So after screening, they come to the eligibility stage, which is assess full article. So the article will be assessed fully, and also they have categories to assess it. And full text articles excluded is to 24 articles that excluded. It is because not a quasi-experimental did not provide sufficient quantitative data. And after that process, it resulted that it obtained 11 paper that can be used to analyze, that can be used to analyze the problem-based learning, the effectiveness of problem-based learning in students' achievement. And that 11 paper were conducted, 2 in Africa, 1 in America, and 8 in Eurasia. In analyzing the data statistically, the researchers utilized the Comprehensive Meta-Analysis or CMA version 3 developed by Biostat. So in this study, the researchers used HGG to compute for the effect size of the data collected. All right. So the result is based on the data. Findings have shown that PBL as an approach to teaching science had a large and positive effect of the amount of 0.871 in effect sizes on the achievement of secondary students. So this number of effect size can be indicated that PBL is an effective learning approach, is an effective teaching approach as applied to different scientific disciplines for secondary students, both in JHS or junior high school and senior high school. Although if we compare junior high school and senior high school that implemented problem-based learning, it said that problem-based learning will be more effective to be applied on adult learning. So because adult has competencies of knowing the they already like knowing what is the purpose of the learning and etc. So but it doesn't mean that in junior high school problem-based learning can be applied, no, but it's just more effective in adult learning. All right, so the conclusion is this research proved that problem-based learning is effective to be used in secondary students' achievement in science. So the next is learning Braille-fied, improving students' scientific literacy through problem-based learning. This paper was published on 2021, written by Nainggolan VA, Situmorang RP, and Hastuti SP. All right. So the background of this paper is students' literacy skills are classified as low. We know that Indonesian students has a low level of scientific literacy skills. Yeah, based on the PISA data, our students, Indonesian students, is still in a low rank. Yeah. And PBL model can increase the ability of scientific literacy. Nevertheless, the research has not focused on empowering students about using scientific evidence and phenomena scientifically. So, yeah, that is the background of this paper. So the purpose of this paper is to describe student scientific literacy in biovita topic using problem-based learning. All right, so basically, this paper was conducted in Kristen Satya Wacana Senior High School. So they do the collecting data in Kristen Satya Wacana Senior High School, and they found that scientific literacy is still low due to several conditions. The first condition is lack of learning activities that lead to scientific literacy, scientific process, and then limited opportunities for teachers to conduct evaluation tools that lead to scientific literacy. And then teachers are still minimal in assisting students to train students' scientific literacy skills and lack of students' assistance in science learning. So researchers found that 26% students uh, commented that biology was about remembering and it sometimes felt confusing. So these were can be indicated that teacher uh, teacher had some difficulties to gain a learning process based on the scientific process. In biology learning, students can answer a question, but it's only the basic answer, the basic questions, not really the high order thinking questions, not really can solve the problem and do the critical thinking in some problems to solve that problems. Yeah, so one of the alternative is to use problem-based learning model in biology learning. And this paper is talk about bryophyte. And bryophyte is one of biology topic that can be created to be the process of investigation. Students will be involved in observing the types of bryophyte and their classification based on students' findings in the environment. All right, so this is the method. The method of this research use CAR or classroom action research. The subjects of this study were 30 students of 10 graders at Kristen Satya Wacana Senior High School of the academic year 2019-2020. And the implementation of PBL models is analyzed through the calculation of average scores using endgame. So in this method, or in CAR method, there are but there are a step which the first is pre-cycle, and then cycle 1, and then cycle 2. And to calculate the average score, the researchers make test instrument that consists of 3 indicator items. That 3 indicator items are identifying scientific problems, explain phenomena scientifically, and using scientific evidence. With 15 multiple choices and 5 essays, and these 20 test items what were implemented in 11 grader students that already passed the bryophyte chapter, that already learned about bryophyte. And these 20 test items were declared as valid uh, with Conbrach alpha reliability of 0.84. All right, so the pre-cycle and cycle 1, cycle 2 consists of plan, do, observation, and reflection. In the pre-cycle, plan in plan, it's design a learning implementation that uses problem-based learning. This I'm sorry. The PBL phase is problem identification, collaborative problem solution, presentation, and evaluation in pre-cycle. And for the do step, the teacher used the PBL model designed as authentic problems which were structured and simple characteristics. And then for the observation, students identified problems related to video and make their arguments. And for the reflection, teacher give feedback according to students' answer. The cycle 1 is more what it's uh, more more implementing the problem-based learning, because in the cycle 1 in PBL based that implemented is observing, asking questions, collecting data, and then associating and communicating. And plan in plan step in cycle 1 is design a learning implementation that uses problem-based learning such as student worksheets and evaluation tools. For the do, identifying bryophyte structure based on worksheet. For the observation, answer questions about the types of problems given and still limited to memorizing and remembering questions. And for the reflection, teachers got students to be guided to discussion delivered in the form of text identifying unstructured problems. And the cycle 2 is fully implemented the problem-based learning model. The plan in cycle 2 is design a learning implementation that uses problem-based learning as student worksheets for laboratory, create key determination guidance and evaluation tools. For the do, collecting bryophyte sample and identifying the samples in the laboratory. For the observation, make good decisions about bryophytes, small group collaboration, and teams show their effort according to the result scientific activity. The reflection, by giving laboratory activity, students gathering can produce an explanation combining their general knowledge. All right, so this is the result. In the pre-cycle, based on the observations, teachers have not implemented the PBL model optimally. As we can see in here, in the percentage of completeness, it's only 13%, and percentage of incompleteness is 87%. So it means that the PBL model was not optimally implemented. And this is the cycle 1 and cycle 2. The comparison between cycle 1 and cycle 2. The data of cycle 1 and cycle 2 is show that students' scientific literacy in cycle 2 have completed because appropriate with the expected target. So in cycle 1, uh, student participation is still not optimal, and although the PBL carried out almost entirely, but students' participation is still not optimal. So the cycle 1 still has incomplete criteria, as we can see in this table. And for the cycle 2, the criteria was complete, and the point of achievement is more than 70 points. Alright, so the conclusion is the results of the study have implications in the learning process, which can be used as a reference for developing student scientific literacy through problem-based learning in scientific activities. All right, let's jump to the third paper, the effect of STEM instruction on attitude, career perception and career interest in a problem-based learning environment and student opinions. This paper was published in 2018 and written by Sari U, Alice M, and Sen O F. I don't know how to read it actually. I'm sorry if I read it wrong. All right, so this is the background of this paper. So the STEM disciplines have shifted from a traditional teaching method to a student-centered teaching, such as problem-based learning. And PBL is well suited for engineering and other STEM disciplines because it helps students develop skills and confidence to solve real-life problems they have never encountered before. And the purpose of this research is aims to find the answers from these questions. The first one is, do the students' existing attitudes towards STEM disciplines vary significantly after PBL activities? Do the students' career perceptions vary significantly after PBL activities? What are the frequencies related to the students' interest in STEM-related occupations before and after the implementation of PBL activities? And what are the students' opinion about the problem-based STEM activities? All right. So the this research use mixed method, which is qualitative and quantitative. And also the single group pretest post-test experimental design was used. And this paper was conducted with the fifth grade students in a state school in the city of Ankara, Turkey. So the mixed method is consists of qualitative and quantitative, right? And in the quantitative part of the study, student attitudes towards STEM scale, the STEM semantic survey for career interest, and the frequencies related to the students' interest in STEM-related occupations before and after the implementation of PBL activities. The Wilcoxon sign rank test was used to test whether there was a significant difference in the students' STEM attitudes and career interests before and after the application. In qualitative part of the study, in order to elicit students' opinions about the problem-based STEM activities, the STEM interview form was conducted by the researchers after the STEM activities. All right. So in quantitative study, in the part of quantitative, The researchers used the students' attitude toward STEM scale and the survey of the STEM semantic for career interests and frequencies related to the students' interest in STEM-related occupations before and after the implementation. And for the qualitative, uh, researchers interview form, use an interview form about STEM and was conducted by the researchers after the STEM activities. So this is the result and conclusion. The result of student attitudes, which is a which is that is a significant uh, it it was found that there is a significant difference between students' STEM attitude scores taken before and after the application. It has the score 2.61. The P is below than 0.01, which means it was found that there is a significant difference between students' STEM attitude scores taken before and after the application. And for the career interest, there is also significant difference between students' pre-test and post-test scores taken from the career perception test. With the Z amount, with the Z value is 3.6868, and P is below 0.05. And then for the occupation frequency, students became more interested in careers related to STEM disciplines after the implementation of PBL. As you can see in here, there are some fields: physics, science, life science, technology, engineering, and mathematics. And then it is pre-test and protest result, post-test results, I'm sorry. So this is the percentage of interest students and not interest students. So in physics science, in pre-test, students' interest is only 45.5%. And in different with life science, it has a big percentage in interest for the pre-test, which 68.2%. And also in mathematics, it has a big interest than not interest percentage in mathematics in pretest, which 54.5 percentage. And after implementing the problem-based learning, they will get the post-test result, which is we can see in physics science for the interested is significantly gained. It's become 86.4%, and almost all the fields has the bigger interested than not interested in the post test. So that means students become more interested in careers related to BBL, related to STEM disciplines after implementation of PBL. And then students' opinion, the last one. So students' opinion is about interviewing the students, and it was found that high majority of the students are of the opinion that the problem-based STEM activities increase their interest in science, and that they want such activities to be incorporated into science classes. It means that problem-based learning is successfully engage students' interest in learning, right? And for the conclusion, as a result, integration of PBL with STEM positively affects students' attitudes and career perceptions that are in the pursuit of their future career. All right, so the next is the effect of problem-based learning on metacognitive ability in the conjecturing process of junior high school students. This paper was published in 2022 and written by Dwi Hastuti, Fuster Guilen, Palacios Garay, Hernandez, Namaziandos. The background of this study is metacognitive abilities are an indicator emphasized in achieving learning goals because they can encourage higher order thinking skills. So, one of the solutions to improving students' metacognitive abilities is through student-centered learning activities such as problem-based learning. And purpose of this study is aimed to analyze the effect of problem-based learning on metacognitive abilities in the conjecturing process of junior high school students. All right, let's jump to the method. This study employs a mixed method, which is a combination of quantitative and qualitative methods, same as a previous study. And the population of this study was the 8th grade students of MTS in West Mataram City of Indonesia. And the study collecting the data and analyzing them through the independent sample test, t-test, sample t-test. So the step of the method is prepare two groups. So the researcher prepared two groups, namely the experimental class and the control class. The experimental class will be implemented problem-based learning activities, and for the control class, they will be implemented the conventional learning. And then after that, giving a pretest to each group, namely experimental and control group. And then after that, it's validation process. The validation process is about validate the student worksheet, lesson plan, and then pretest and post-test question, and it's validated by the expert. And then treatment process is about implementing the problem-based learning in experimental and conventional learning in control group. And then after that, we'll be giving a post test. So this step is the researchers the researchers do in collecting the data of this paper. And we can see this is a model of triangulation. All right. Actually, it is the same, yeah. This is only the step. So there are quantitative and qualitative data because it is mixed methods. And quantitative data consists of experimental class and control class. And then it will be collecting the data and analyzing the data through the independent sample test. And then for the qualitative data is what the it's gain it's collecting the it met it's collecting the metacognitive skill in conjecturing process, and then the researchers will interview the selected subjects, and then data analysis, and then the research results. All right, that's all for the method and the result. We can see in the pretest, the p-value was larger than the significance level. The p-value is more than 0.05. Hence, it could be inferred that the learners in the two groups were at the same level before treatment. While in post-test, as we can see in here, the mean is not really has a big difference, right? So yeah, we can infer that the learners in the two groups were at the same level before treatment. And after the treatment in here, the post-test, it has the significance level. The P is below 0.05, which means there is significant level. As we can see, experimental class is bigger in mean than control class. So the conclusion is PBL had a significant effect on the metacognitive abilities of students' conjecturing process in solving pattern generalization problems, because this paper conducted the mathematics learning that using problem-based learning. All right. So the fifth one, the last one of the paper, is the effect of problem-based learning model on students' self-concept and metacognitive ability on expression system. Was published in 2022, written by Siregar N. and Julia A. Julia E. All right. The background is students should have at least two competencies to achieve learning objectives, including metacognitive abilities and the self-concept. We already know what metacognitive is, but what is self-concept? Self-concept is the ability uh, to know the interest, to know the skill of the self-concept is ability of students to know their interests, their what their ability to learning, like that. And then one alternative learning model that can develop a positive self-concept and train students' metacognitive abilities is the problem-based learning model. So the purpose of this study is to determine the effect of the problem-based learning model on students' self-concept and metacognitive abilities. So here is the method. The type of research in the study is quasi-experimental. The study used a pre-test, post-test, non-equivalent control group design. And the research population is students of class 11 in MIA Mandua Deli Serdang, which consisted of 3 classes with 104 students. They choose 2 classes, namely 11 MIA 3 for the experimental class, and will become experimental class, and 11 MIA 1 will become control class. The data analysis technique use descriptive statistical analysis and inferential statistical analysis. The data obtained in this study is a type of quantitative data. So the study is used quasi-experimental, which consists of two different groups. The first group is experimental class, and then the other group is control class. And the step of doing this research is same with previous paper. The first step is prepare two groups, namely experimental class and control class, and giving a pretest to each group, namely experimental and control, and then validation process. It's the same, to validate the lesson plans, student worksheet, and etc. And then treatment process is the implementation of PBL in experimental class, and different with, unlike the previous paper, this paper use discovery learning to be implemented in control class, and then after that it will giving a post test. All right, so the result, we can see the table 1 is the result of the self-concept hypothesis test after learning activities. It shows significant value of PBL is lower than alpha with number 0.000, as well as in discovery learning with significant value 0.009. Thus, it can be concluded that hypothesis is accepted, or we can say that there is an effect of the problem-based learning model on students' self-concept. We can see in here. There is a significant difference between the pretest and post-test scores in problem-based learning and direct learning. I don't know. It can, in this paper actually it said that discovery learning, but in here it's direct learning. Actually, I don't know which one is right. Okay, so table 2 is the hypothesis test result of metacognitive ability after learning activities. It shows significance value of 0.000, which is below 0.05 in the experimental class that use problem-based learning, and it shows and 0.000 below 0.05 in the control class in direct learning. Thus, it can be concluded that HA is accepted. There is an effect of the problem-based learning model on students' metacognitive abilities. So for the conclusion, the problem-based learning model has a significant effect on students' self-concept and metacognitive ability on the excretory system. All right, so I think that's all from me. Yeah, I hope my presentation will give you more insight about problem-based learning. So I think that's enough. Thank you for your attention, and wassalamualaikum warahmatullahi wabarakatuh.